Hello everybody. Today I'll be showing you how to do the flow simulations for LBR. All this information is from what we have gathered so far. For any updates, please contact your leads. So now let's start. So first we're going to want a flow simulation to appear in this upper corner. So first we're going to put under, we're going to go to this gear icon, click the arrow, add-ins, scroll all the way to the bottom, flow simulation 2021. Okay. It then might take a while. It should flicker the screen and here it appears. Under flow simulations, you're going to click wizard. We're going to call it project 1. Next, we then use FPS. The velocity should be in feet per second. That's one way to verify. Next, external. Click both of these values. Then we're going to want gravity. Gravity, as you see, is pointing to the side. This is incorrect. We are going to want it to appear in the X direction. It should appear like this. We then are going to click next. Gases, air, add, and it should appear right here. Then we're going to click next. For roughness, for microrange, it is not needed for flow simulations. We then click next. For velocity, in the same direction as gravity, we're going to input it. In this example, we'll do 500 feet per second and finish. This should appear. In past years, I have noticed that this flow simulation analysis is in this corner, is in actually this bottom corner. Currently, it appears here. So if you don't see it right here, it might also be down here. Project. You're going to see this domain. This domain is the computational domain. You can add it, you could shrink it, and then shrink it down if needed. The smaller this domain is, the less computer power is required. We are going to want to add some goals. We're going to insert global goals. We're going to want static pressure, total pressure, velocity in the X direction. Click the check mark. You're then going to want to add another goal of the normal force in the X direction. Click OK. We are then just going to change the name of this to drag force. And lastly, for goals, you're going to want to insert global equation. This global equation is going to be the drag force times 2, finish parentheses, divided by 0.00277 times 0.15033 times 500 squared. This equation is found right here. So this is the drag coefficient equation. So we're going to have 2 times the drag force divided by the mass density of the fluid, which would be air. And this is 0.02377. So I forgot a 3 right here. Slug divided by feet per second times the flow speed of the object relative to the fluid, so the velocity squared, which is 500 feet per second squared, times the area, which is the 0.15. Because this has a diameter of 5.25 inches. We're then going to click OK. We are then going to want to insert a global we're going to want to click global mesh. Put the setting all the way to a 1. Typically, the higher the setting, the more accurate the value is. But for flow simulations, it is not required. Click the check mark, and you should be ready to go. And up here, in the upper, just click run. run, and it's gonna start putting in the iteration. This time depends heavily on your computer specs and the computational domain. Well, it's already finished for me. Results for the drag coefficient, we're gonna put insert equation goal number 1, show. Here we see a drag coefficient of 0.294. We're gonna put add drag force, show again, and we have a drag force of 13.125 IBF, the normal force in the X direction. I'm gonna click check mark because we're done with that. Now, to have the surface plots, right here, surface plots, insert, we're gonna wanna click the surface areas, which would be these two, check mark, and here it is. To get rid of this computational domain, you right click it right here, and press hide, just so when you take pictures. And this is movable. Then to hide it, put hide all. Now to flow show the flow trajectories, put insert, click this singular face, the head only, not the shoulder, check mark, and here it is. And this is what you'd use for pictures. This is IDES simulation for a nose cone. For the fins, it is slightly different. So here, for the flow simulation of the fin, you're going to want to CAD the full rocket with the fins itself. And this is going to be your simulation. And then for the drag coefficient equation, the area is the reference area is going to be this. So it's going to be 4 rectangles time plus the area of the circle right here. Thank you.